Hello, and welcome to our Getting to Know Batfish demo series, where we showcase key capabilities of Batfish and how they can be used as part of your network automation workflow. My name is Samir, and I will show you how to analyze routing tables using Batfish. In this demo, I will utilize a Jupyter Notebook to interact with PyBatfish, the Python SDK for Batfish. I will also utilize the Pandas data analysis library. So let's get started. These first two cells import the required modules and initialize a snapshot of the network. A snapshot just contains the data you want to analyze, and it can include network configurations or routing information. This data could be pulled from the live network or contain candidate configurations that you want to analyze before deploying to the network. I'm going to use an example network, which is included in the PyBatfish GitHub repository. It showcases all of the basic networking concepts and constructs. For routing, we have multiple BGP autonomous systems and OSPF within each AS. For security, we have ACLs on routers and IP tables on hosts. Now, this picture here is just there for reference. All the information you're going to see in this notebook is dynamically computed by Batfish based on the configuration files for the network devices. As you know, Batfish builds a vendor-neutral data model from the network snapshots. And these models can be queried using a set of questions that we provide. Now, based on this vendor-neutral model, Batfish computes the ribs and fibs for all the VRFs on all the devices in the snapshot. So let's query Batfish for these routing tables. Now, this question is going to generate a lot of data, so I'm not going to print it here. But what you can do is you can filter the results to get a more manageable subset of the information. Let's filter the results and view the routes in the default VRF, or global routing table, on the border routers for AS1. There are two ways we can filter the results. We can pass in parameters to the routes question and ask it again, or we can filter the output of the original question since it is a Pandas data frame. To see the parameters to pass into the routes question, run !bfq.routes. This will show you the question description, the various parameters it'll accept, the default values, and the parameter types. So to get the subset of results I want, I'm going to pass in node equals AS1 border.star and verse equals default. Now, if I want to use the Pandas filtering for it, what I'm going to do is I'm going to search for the string AS1 border in the column node, and I'm going to search for the value default in the column for verf. As you see, this is a much smaller subset of data, much more manageable. The other thing you should recognize are the column headers. They're common fields that you would see when you run the command show IP route on any router. You see fields like the network, the protocol that installed the route, the metric of the route, the next hop IP, etc. Now, throughout this notebook, I will show you how to use both of these filtering mechanisms to get the subset of information you want from Batfish. So even the previous output was quite large. Let's say we wanted to filter it down even further, and we just cared about the BGP routes in the default verf on AS1 border routers. Again, there's two options to do it. I can pass an additional filter into the routes question for the protocol equals BGP, or I can add to my Pandas filter and also filter on the column protocol looking for the value BGP. Both of them give me a much more manageable set of data. Now, the Pandas data library is very powerful. So if you want to do some more advanced filtering, that is what I'd recommend to use. So let's say I wanted to find all BGP routes on all verfs on all routers where the metric is greater than or equal to 50. This is definitely something I would use the Pandas filtering for. And I would use the original routes question. I would look for protocol equals BGP, and then I can select the metric column and look for values that are greater than or equal to 50. And now what you see here is all the routing entries on all the devices across all the verfs where the metric is 50 and the protocol is BGP. So this gives you an idea of how to use filtering to get specific information you want from the routing tables generated by Batfish. Let's see how you would troubleshoot a network connectivity issue. Let's say you were trying to figure out some connectivity issue with a subnet 1.0.2.0/24. The first thing I would do is run the routes question for that specific network. And what I see here is the entry for 1.0.2.0/24 across all nodes, across all verfs in the network. Now, what I'm really interested in is the list of nodes that have this routing entry, not the specifics of those routing entries. So this is where pandas filtering comes in handy. I will filter the routes based on the column node and just look for the unique set of entries and print that out on the screen here. So this here is the list of all the nodes that have a routing entry for that prefix. Now that's interesting information, but what's more interesting is the list of nodes that do not have this prefix in the routing table. And again, this is very easy to do with pandas using their group by and filter functions. So what I'm doing over here is I'm looking for all network entries that are not equal to 1.0.2.0/24. And I'm going to group them by node, and I'm going to sort them. And then I'm going to print that out. And so that's what you get here. What I see here is only the two hosts don't have a route to 1.0.2.0/24. This is as expected because they should really just have a default route. But we can verify that by looking for the routing tables on the hosts. And by basically looking for host in the node column of the route's answer, I can see the routing tables for the two hosts. And as I suspected, they have their own IP address as a local route, the connected subnet, and a default route that's configured as a static route, which is how we model default gateways in Batfish. So everything is as expected here. As you can see, with Batfish and Pandas, you can easily retrieve the exact information you are looking for from the routing tables on any or all network devices for any or all VRFs. Thanks for watching this demo about how to analyze routing tables with Batfish. Stay tuned for future videos in which we will dive into deeper routing analysis and validation. In the meantime, use the link in the video description below to check out this notebook and several others that are available on GitHub and start using Batfish to proactively validate your network. Thank you.